So this is question number 5. We are asked to solve 6 times root of y positive 2 over root of y negative 7 is equal to 0. There's two parts here, a and b. Next one is hence solve the equation. 6 times the root of tan x positive 2 over root of tan x negative 7 is equal to 0. For 0, or I would say for x lying between 0 and 360 degrees. Okay, so this is the requirement. So we start off with the first part. We're given that 6 times the root of y positive 2 over root of y negative 7 is equal to 0. Now let me take root of y to be equal to, say, some z. Now squaring both sides, what do we get? We get, so I square both sides, I would get z squared is equal to y. Right? And if I were to take this as 1, I can make the following substitutions. So wherever I get y, I can substitute z squared, and wherever I see root of y, I can make the substitution as z. So therefore 1 becomes, so 6 times root of y, I have just taken root of y to be as z. So this is z, so root of y is taken to be as z. Positive 2 over z negative 7 is equal to 0. I need to get rid of this z. So multiply by z both sides. We get, so what do we get? 6 times z into z squared, positive 2 z and z gets cancelled, negative z times, or I would say negative 7 times z is equal to 0. So this is rewritten as 6 times z squared, negative 7 times z, positive 2 is equal to 0. Now what I will do is I will use quadratic. So a is 6 and b is negative 7 and c is equal to 2. We will utilize this formula. Z is equal to negative b plus or minus root of b squared negative 4ac divided by 2 times a. So negative of negative 7 plus or minus root of 7 squared, negative of 7 squared, negative 4 times a times c is 2 divided by 2 times a. So this is 7 plus or minus 7 squared is 49, 4 times 2 is 8, that's 48 divided by 12. So this is equal to 7 plus or minus root of 1 divided by 12. So this is what we've got. So let me, so 7 plus 1 and we have a 12 there, right? Right? This is what we've got. So this is z equal to, and the other side is z is equal to 7 minus 1 over 12. So this would give you 8 over 12. 4 divides 2 times 4 divides 3 times. So therefore z is equal to 2 over 3. And z is equal to, this will give you 6 over 12. 6 divides 1, 6 divides 2 times. So z is equal to 1 over 2. But what did I do? I take z to be equal to root of y. So substitute that there. So this means root of y is equal to 2 over 3. And I square both sides. I would get y is equal to 4 over 9. So that is one part. And the next part is root of y is equal to 1 over 2. I square both sides. I get y is equal to 1 over 4. So therefore we are just asked to solve, right? So therefore y is equal to 1 over 4 and y is equal to 4 over 9, and block it. Now let's do the next part. We have been given 6 times root of tan x, positive 2 over root of tan x. Okay, negative 7 is equal to 0. We are asked to solve. So this is part B. We are to solve 6 times the root of tan x, positive 2 times the root of tan x, negative 7 is equal to 0. I know that we can directly extract the values of tan x from the previous working, but I don't want to do that. I want to show the process. So I'm going to say let z be equal to root of tan x. So if I were to take this as 2, therefore 2 can be rewritten as 6 times z with positive 2 over z negative 7 is equal to 0. So multiplying throughout by z, we get, so 6 into z, z squared, negative, or I would say positive, this z gets cancelled with the negative z being obtained here because we are multiplying by z both sides. So this is 0. Now this can be rewritten as 6 times z squared, negative 7 times z, positive 2 is equal to 0. I'm going to use the quadratic formula. A, or I would take the value of a as 6 here. It's because we have this equation as 6z squared. So a is 6 and b is negative 7 and c is 2. So we will utilize this formula. Z is equal to negative b plus or minus root of b squared negative 4ac divided by 2 times a. We substitute the values. So z will be equal to negative of negative 7 plus or minus negative 7 squared negative 4 times a is 6, c is 2 divided by 2 times 6. So this is going to be 7 plus or minus root of 7 squared is 49 minus 6 fours are 24 times 2, that's going to be 48 divided by 2 times 6 is 12. So this would give you 7 positive 1 over 12, that's one value. Next value 7 negative 1 over 12. In both cases we got z and z. So when z is equal to 8 over 12, this would be 4 will divide here 2 times, 4 divides here 3 times. So z is equal to 2 over 3. And for this, z is equal to 6 over 12. So that means z is 1 over 2. So z is 1 over 2 and z is 2 over 3. So let me move up here. So therefore z is equal to two values, 1 over 2 and 2 over 3. Z is 2 over 3. But what is z? Z is nothing but root of tan x, right? So this would mean root of tan x is equal to 2 over 3. I square both sides and I would get tan x is equal to 4 over 3. Now this means x is equal to tan inverse of 4 over 3, which means x is approximately, you utilize your calculator and you will get 24.23 degrees. But we are given, what are we given? X is actually lying between 0 and 360 degrees. And tan is positive in the first and third quadrant, right? So this would mean x is 24.23 is one value and then x is 24.23 plus 180 is another value, which is going to be 204.23 degrees. So you can write that down here. So therefore x is approximately 24.23 degrees and x is approximately 204.23 degrees. So this is one part. Now there's another part we have to do for 1 over 2, right? Also root of tan x is equal to 1 over 2, so you square both sides. So this means tan x is 1 over 4, so x is tan inverse of 1 over 4. Now what is that? That would give a value of approximately 14.04 degrees. Now by the same concept, I would say that probably you can write that since tan x is positive in the first and third quadrant. Okay, this would mean you would have, I'm going to utilize this space, x is approximately 14.04 degrees and x is approximately 14.04 degrees plus 180 degrees. That means x is approximately 194.04 degrees. So that conclusion you will have to state. Okay, so you can block this off along with the previous conclusion. The two solutions are there, so the other one is over here, right? So you will have to exclusively show this, that you have actually realized the existence of these solutions. So having mentioned that, let's move on to the next one.